Alright, we're going to start off this video talking about the 7 fundamental units. These are your 7 SI units. SI from the French Système International, or Système International des Units. There they are: mass, time, length, temperature, electric current, amount of a substance, luminous intensity, the candela. We won't deal with the candela, but these other 6 absolutely for sure. It's useful to memorize this whole table. Then from the fundamental units we can take and we can derive any other unit. For example, if we take force, which we know to be F equals ma, and we know that force is measured in newtons, but we have kilogram times a meter per second squared. Remember, this is your SI unit for mass, SI unit for length, SI unit, well, not the squared, but the SI unit for time is seconds. So using a combination of these, we have our newton. This is what's called a derived unit. Alright, so let's go ahead and get that out of there. Next up, we have our metric prefixes. I have a little mnemonic device to help remember. The grumpy man kicked his dog down a cement mixer, making noise probably. Extremely violent and terrible, but it works, so deal with it. We have the metric prefix TG, M, K, H, D. We don't use hecto or deca. I mean, it's just not really useful. We would just say 100. We wouldn't say 1 hecto. We would say 100 meters, not 1 hectometer. But then anything above 1,000. But below deca, you'll notice the letters go from capital to lowercase. This is purely by design. So you have this kind of line right here. Once you pass that, that would be like 10 to the 0th power. Once you pass that, then you're down in numbers that are smaller than 1. So anything above the line is numbers bigger than 1. Below the line is numbers smaller than 1. Also notice the pattern. 12, negative 12, 9, negative 9, 6, negative 6, 3, negative 3, 2, 1. So hopefully that lets you kind of have this. By no means do you have to memorize this. If you're taking an exam, it's going to save you some seconds though. Scientific notation. Alright. We're going to use when numbers are bigger or smaller than 1,000. So that's a typo. Bigger than 1,000 or smaller than 1,000th. So 0.00. Ideally, you're going to have 1 significant digit, but 2 is okay, for sure. Did he just say Sig Figs? Yes, Sig Figs. You remember those? If you don't, here's your rule for counting them. This is, if you've got a decimal present, P for present, Pacific Ocean. So Pacific Ocean to us is on the left side. Atlantic Ocean is the other one, so that's on the right side. So if a decimal is present, we're coming from the Pacific or the left side, looking for the first non-zero. So here's a little check. Go ahead and pause in between each one of these to tell me how many Sig Figs are there? First question. Is there a decimal present? Alright, whenever there's a decimal present, we're coming in from the left. So, looking at this 7,000 with a period, with a decimal, we're going to start here, 7, so that's 1, 2, 3, 4. Again, decimal present, so we come from the left until we hit the first non-zero, and there we go. 1,020, come in from the right because there's no decimal. Propagation. of sig figs, which just means doing math with sig figs. To multiply and divide, we're going to use the number of sig figs of the least precise number. And if we're adding or subtracting, we're going to use the number of decimal places of the least precise number. For example, multiplying, we have this number times this. 2.01 is less precise. There's less numbers after the decimal, so we're going to use that number of sig figs. And this one there happens to be 3, so we're going to use 3 sig figs for our answer. If we're adding or subtracting, again, 2.01 is the least precise, so we're going to use that number of decimal places, 2. A lot of times they're going to be the same, so when in doubt, just use the smallest number of decimal places, because you can't have an answer more precise than the measurement you started out with.